Today we're going to start with your chemistry class. This is your class 34, which is your unit 11, that is the P block element that we have to continue here. In this, we will start discussing about the carbon dioxide, where we had in the last class we discussed about chemical carbolysis and your complex with hemoglobin. Now we'll discuss about the carbon dioxide, so let's go for the same. But before starting with the same, it's a huge request to all the viewers. Please go ahead with like, share and subscribe so that many and maximum people can get the information at once, and even you can also enjoy the video as well. So starting with carbon dioxide. So in terms of carbon dioxide here, that it is prepared by a complete combustions of carbon and carbon containing fuel in excess of fuel. Carbon containing fuel in excess of air. So we have a reaction here, that is carbon form of solid plus O2 form of gas in the presence of heat will give carbon dioxide, that is form of gas. Now CH4 gas plus 2O2 gas. So when that we'll go for the next equation here, that we completed here. So for CH4 plus O2 in the presence of heat, it will give carbon dioxide gas plus 2H2O, which is in the form of gas. In the laboratory, it is conveniently prepared by the actions of dilute HCl on calcium carbonate, so that is CaCO3 solid plus 2HCl, that is in aqueous, will give CaCl2 aqueous plus CO2 gas plus H2O liquid. That what we have here. Now we're going to continue with the next equation that we have. With the same, on the commercial scale, it is obtained by the heating limestone here, and that is considered to be, now it is the colorless and odorless gas, and it is also low solubility in the water, that makes of immense biochemical and geochemical importance with water. It forms carbonic acid H2CO3, which is weak dibasic acid, and dissociations in two steps, that is comes under H2CO3 aqueous plus H2O liquid. It will give HCO3 minus aqueous plus H3O plus aqueous, and HCO3 minus aqueous plus H2O liquid, CO3 2 minus aqueous plus H3O plus aqueous, that is H2CO3 and HCO3 minus buffer system that helps to maintain pH of a blood between 7.26 to 7.42. Being acidic in nature, it combines with alkalis to form metal carbonates, where in the carbon dioxide, which is normally present to the extent of near about 0.03% by volume in the atmosphere, and that is removed from it by the process known as a photosynthesis. It is the process by which the green plants convert atmosphere CO2 into the carbohydrates such as glucose, and the overall chemical change that can be expressed here, which is 6CO2 plus 12H2O in the presence of HV, chlorophyll, C6H12O6 plus 6O2 plus 6H2O. That is by the process that plants makes food for themselves as well as the animals and the human beings. Unlike carbon monoxide, it is not poisonous, but the increase in the combustions of fossil fuels and decompositions of limestone for the cement manufacture in the recent years that seems to increase the manufacturing recent year, which is seem to increase the carbon dioxide content of the atmosphere. This may lead to the increase in the greenhouse effect and thus raise the temperature of the atmosphere, which might have serious consequences. Carbon dioxide that can be obtained as a solid in the form of a dry ice by allowing the liquefied carbon dioxide to expand rapidly. Dry ice is used as a refrigerant for ice cream and frozen fruit. Gaseous carbon dioxide is extensively used as a carbonate soft drinks, being heavy and non-supporter of combustion, and it is used of fire extinguisher. A substantial amount of carbon dioxide is used to manufacture urea as well. In the same way, in the carbon monoxide molecules, that carbon atom undergoes sp hybridization, and two sp hybridized orbital of carbon atom that overlap with two p orbitals of the oxygen atom to make the two sigma bonds, while other two electrons of the carbon atom that are involved in p pi and p pi bonding with oxygen atom. This results in its linear shape with both carbon monoxide and bond of equal length 115 ppm with no dipole moment, and the resonance structures that are shown here is this is the resonance structures of carbon dioxide. Now we go for the silicon dioxide that we discussed here in the detail. SiO2. Here the 95% of the earth crust is made up of silica and the silicates, and that the silicon here the silicon dioxide, commonly known as your silica, and occurs in several crystallographic forms, and that is quartz, cristobalite and tridymite are the forms, and quartz and cristobalite and tridymite are some of the crystalline forms of silica, and they are interconvertible at suitable temperature. Silicon dioxide is a covalent and three-dimensional network solid in which each silicon atom is covalently bonded in the tetrahedral manner to the four oxygen atom. Each oxygen atom in return of the covalently bonded to the another silicon atom, as I will be going to draw here. Each corner of the shared and the another tetrahedron, that the entire crystal that may be considered as a giant molecule. and in which the 8 members rings are formed with the alternative silicon and oxygen atoms. So for that, we will be going to draw here, and that is in the same way that silica and its normal form is almost a non-reactive because of the very high Si and O bond and enthalpy, and it resists the attacks of by the halogen and the dihydrogen and the most of the acids and metals. Even in the elevated temperature, however, it is attacked by HF and NaOH. It will give SiO2 plus 2 NaOH will give Na2 SiO3 plus H2O. The second is SiO2 plus 4HF will give SiF4 plus 2H2O. So here the quartz is extensively used as a piezoelectric material. It has made it possible to develop the extremely accurate clock and the modern radio, television, broadcasting and mobile ratio communication. For the silica gel is being used for the drying agent as in support for your chromatographic material and the catalyst that your Kesselger and the amorphous form of silica that is used in the filtration plant. Let's go for the same. So although that the P block of the periodic table that is unique in terms of having all types of element, that is metals, non-metals and metalloids, there are the 6 groups of P block elements in the periodic table that numbered from 13 to 18, and their valence shells electronic configuration is ns2 and p 1 to 6 as well, that except of helium, and the difference in the inner core of their electronic configuration that is greatly influence their physical and chemical properties. As the consequences of this, a lot of variation in the properties among these elements is observed, and in addition to the group, the oxidation state, and that these elements shows the oxidation state differing from the total number of valence electron by the unit of 2, and while the group of the oxidation state is the most stable of the lighter element of the group, lower oxidation state and that group your progressively more stable heavier element, and that the combined effect of the size and the availability of the d orbital considerably influence the ability of these elements to form pi bonds, while the lighter elements form p pi bonds, and the heavier ones form dx px and d pi and d pi bonds. In absence of the d orbital in the second period, element limits their maximum covalence to 4, while the heavier ones that can exceed this limit as well. Now coming toward the boron, that is a typical non-metal, and the other members of the metals that have the availability of the 3 valence electron 2s2 2p1 for the covalent bond that formation, but the 4 orbital 2s 2p 2 py and then 2pz leads to the so-called electron deficiency in the boron compound, and this deficiency makes them a good electron acceptor, and thus boron compound behave as Lewis acid, which is diborane, and B2H6 that the diborane contains the 2 bringing hanging your hydrogen atom between the 2 boron atoms, and that the important compounds of the boron and the dioxygen are boric acid and the borax, and boric acid BO3 OH3 is a weak monobasic acid, and it acts as Lewis acid by accepting the electrons from hydroxyl ion. Borax is a white crystalline solid of formula, and the borax bead test gives the characteristics colors of the transition metal as well. Aluminium exhibits +3 oxidation state, with the heavier element +1 oxidation state, gets progressively stabilized on going down the group, and this is consequence of the so-called inner pair effect as well. Now coming towards your carbon, that is a typical non-metal forming covalent bond that employing in its all 4 valence electron to s2 to p2, and it shows the property of the catenation, the ability to form the chains and rings, not only carbon-carbon single bond but also with the multiple bonds, and that the tendency of the catenations decreases. Carbon provides one of the best example of allotropy, and the most important allotrope of the carbon are diamond, graphite, and best example fluorine. The members in the carbon family mainly exhibit +2 and +4 oxidation states. Compounding the +4 oxidation state that are generally covalent in nature, the tendency to show +2 oxidation state increases among the heavier element. Lead in +2 state is stable, whereas in the +4 oxidation state it is a strong oxidizing agent. The carbon also exhibits the negative the negative oxidation state, and it forms two important oxide, carbon monoxide and carbon dioxide. Carbon monoxide is neutral, whereas the carbon dioxide is acidic in nature, and the carbon monoxide, having a lone pair of electron on, forms metal carbonalysis. It is deadly poisonous due to the higher stability of its hemoglobin, forms metal carbonalysis, and it is deadly poisonous and for the complex as compared to the oxyhemoglobin complex. Carbon dioxide as such as it is not toxic, whereas however the content of the carbon dioxide is atmosphere due to the combustions of fossil fuels and decomposition of limestone is a featured fairer to the cause increase in the greenhouse effect, and this in turn raise the temperature of the atmosphere and causes the serious complications. Silicates and silicones that are important class of the compound and find application in industry and technology. Now we're gonna here end up with, and we'll discuss the rest in the next coming class. We'll deal with some of the question as well, discuss the pattern of the variations in the oxidation state, that is B to TL and C to PB. How can you explain higher stability of BCl3 as compared to the TiCl3? Why does boron trifluoride behave as a Lewis acid? Consider the compound BCl3 and CCl4. How will they behave with water? Justify. Next is boric acid a protic acid? Explain what happens when boric acid is heated. Next is to describe the shapes of BF3 and BH4 minus. Assign the hybridization of boron and these species. Another is the right reaction to justify the amphoteric nature of aluminium. Let's end up here. So thank you. Hope you enjoyed this video. If you like this video, please give a thumbs up and give a suggestion on the comment box. Please like, share and subscribe. Thank you.